Hello, hi everyone. Welcome to the Student the Brand. This is Sir. Today we are going to discuss about electric current. Electric current, CBSE Grade 10 Physics. Electric current, CBSE Grade 10 Physics. So let's start the topic. Electric current. Hi everyone. Welcome to the class. Electric current. Electric current. Okay, so SI unit of current is ampere, SI unit of charge is coulomb, SI unit of current is ampere, SI unit of charge is coulomb. Okay, so here you can see, now we are going to discuss about electric current, CBSE grade 10 physics. CBSE grade 10 physics, right? Yes. So I equal to Q by T, I equal to Q by T, SI unit of current is ampere, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. So I equal to Q by T, 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Right? So I hope it is very clear. So I equal to Q by T. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. Right? Yes. Now we can see, so in the conductor number of charges are moving. In the conductor number of charges are moving. So only 1 electron flows, only 2 electrons flows, only 3 electron flows, we can't say current is flowing. So there are number of charges are moving in the conductor, then only we can say current is flowing. Right? So here you can see, so charge is, now in this case, it is called quantization of charge. Quantization of charge, that is Q equal to plus or minus Ne. Q equal to plus or minus Ne. So N is the number of charges are moving in the conductor, number of electrons are moving in the conductor, that is nothing but plus or minus. Sir, why you are taking plus or minus? So positive charges are moving, at the same time negative charges are also moving, that's why we are taking plus or minus Ne. Okay, so done. Now you can see here, on one electron 1.6 into 10 power minus 19 coulomb. On one electron 1.6 into 10 power minus 19 coulomb. In one coulomb, okay, so in 1 coulomb, if you are taking 1 coulomb, 1 by 1.6 into 10 power minus 19, so that is nothing but, so 1 by 1.6 into 10 power 19, then you'll get so 0.625 into 10 power 19. Then if you do it, then you will get so 6.25 into 10 power 18 electrons. So in 1 coulomb 6.25 into 10 power 18 electrons are present. I hope it is very clear. Okay, so SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. Okay, so here you can observe this one. Okay, I equal to Q by T. 1 ampere equal to 1 coulomb per 1 second. Q equal to plus or minus Ne. On 1 electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons are present. So this is about electric current and SI unit of current and definition of SI unit of electric current. Right? On one electron, how much charge is present? In 1 coulomb, how many electrons are present? So everything we discuss now. So we will discuss about image for we can say elements. Okay, electrical elements. Let's start. Electrical elements, those are, so electrical elements will discuss, we can see here, electrical elements. First one is cell, this is a cell, positive terminal, negative terminal cell. Second one is battery, positive terminal, negative terminal battery. And the next one is, third one is switch, this is a open switch, and fourth one is closed switch, okay, and fifth one is resistor, this is the resistor. Resistor is the device which is used to oppose electric current. Resistance is the phenomenon of opposing the electric current. Resistor is the device which is used to oppose electric current. Resistance is the phenomenon of opposing the electric current. Okay, so resistor and resistance. Next one, so we'll discuss about rheostat. Rheostat is a device which is used to rheostat. Rheostat is a device which is used to regulate the current without changing the voltage source. Rheostat is a device which is used to regulate the current without changing the voltage source. Okay, so here you can see rheostat. So sixth one is rheostat. This is the rheostat, or we can also take like this, rheostat. Okay, so and seventh one, rheostat is a device which is used to regulate the current. Rheostat is a device which is used to regulate the current without changing the voltage source. Okay, yes. So here you can see. Next one is ammeter. So positive terminal, negative terminal. Next one voltmeter. Voltmeter is a device which is used to measure the potential difference. And the next one is wire joining. This is a wire joining. And 10th one is wire crossing. And 11th one is bulb. Okay, so this is the symbol for bulb. Understood? So cell, battery. So these are the electrical elements. One is cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, and bulb. So here resistor. Resistor is a device which is used to oppose the electric current. So here about resistor we need to discuss few points. First one is resistor, and second one is resistance, and coming to the third one is ohm, and fourth one is symbol for resistance. So resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. Okay, resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current in the circuit. SI unit of resistance is ohm. SI unit of resistance is ohm. Okay, and the symbol for this one, symbol for resistance is this one. So I hope these are the electrical elements. Electrical elements. So now we will discuss about electric circuit. Electric circuit. A continuous and closed path of a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. Understood? Electric circuit. So now we will discuss about electric circuit. Electric circuit. So thank you. So electric circuit, electric circuit, electric circuit. Okay, so here you can observe electric circuit is nothing but a closed and continuous path of an electric current. A closed and continuous path of an electric current is called an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. Okay, so here I am taking this a bulb, and here I am taking the ammeter. So here is the battery switch. So here we'll discuss few points. Current is passing like this, and here positive terminal, negative terminal. Okay, so cell, battery. So first one is conventional current. Conventional current. And the second one is electric current. Okay, so conventional current and electric current. Conventional current is nothing but the flow of positive charges. The flow of positive charges is known as conventional current. The flow of positive charges is known as conventional current. Coming to electric current. So the flow of electrons. Okay, so positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. So here you can see these are the positive charges. Before finding the electron, proton, so already the given statement is, so flow of positive charges will be considered as the electric current. So after knowing the movement of electron gives the electric current. So conventional current. So let it be the flow of positive charges is the conventional current, and electric current is nothing but the flow of electrons. So here you can see. So conventional current. So positive charges are moving from positive terminal to negative terminal. So it moves from high potential to low potential. Whereas electrons will move from low potential to high potential. Conventional current is nothing but the flow of positive charges. Positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. Okay, and one more thing here, high potential and low potential. So positive charges are moving from high potential to low potential. Whereas electrons are moving from low potential to high potential. So kindly do like, share and subscribe to Student the Brand. Okay, so share to everyone and inform to everyone. Let them know regarding the Student the Brand channel. Okay, so conventional current and electric current. So this is the information, and the next one. So we'll discuss about potential difference and electrical potential. Electrical potential. So we'll discuss about those points. Potential difference. Potential difference. Potential difference. So what is potential difference? Potential difference is nothing but work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So I am taking here. So this is a point A and this is a point B. So we are doing some work. So the charge is moving. So we are doing some work. The charge is moving. Okay. Work done to bring unit positive charge from one point to another point. From one point to another point within the conductor. Within the conductor is called potential difference. So V equal to W by Q. V equal to W by Q. So V equal to W by Q. SI unit of potential difference is volt. SI unit of SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. SI unit of charge is coulomb. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. Okay. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Within the conductor is called potential difference. Coming to the electrical potential. Electrical potential. So electrical potential is nothing but work done to bring. So this the charge, it is at infinity. So positive charge is at infinity. So we are doing work. Some work to bring unit positive charge from infinity to the required field. From infinity to the required field. That is called, what is that one? Work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. So this is the required field. We are doing work. So W. So work done to bring unit positive charge from infinity to the required field is called electrical potential. So V equal to W by Q. V equal to W by Q. Okay, SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. SI unit of charge is coulomb. So that is about electrical potential. Potential difference and electrical potential. I hope it is very clear, right? Next one. So we will discuss about one more. That is about Ohm's law. So problems will discuss related to this one. Questions also will come. So we'll discuss those points also. Let's start discuss about problems, everything. Okay. Now, Ohm's law. So Ohm's law is nothing but Ohm's law. So coming to Ohm's law. Ohm's law. So the potential difference across the ends of the given metallic conductor. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. At a constant temperature, very important, at a constant temperature. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. And physical conditions also same. V is directly proportional to I. V equal to IR. So coming to the materials required. What are the materials required? Materials required. First one is 4 cells. So 1.5 volts of each. 1.5 volts of each. First one. Coming to the second one, nichrome wire. So 0.5 meter length. And coming to the third one, 4 cells nichrome wire, ammeter, and coming to the fourth one, voltmeter, and coming to the fifth one, ammeter, voltmeter, switch, ammeter, voltmeter, switch, okay, switch, you can see, switch, and next one, connecting wires, sixth one is connecting wires, okay. So what you have to do, connecting wires. So procedure to do that, okay, what are the things required, once again observe here. So procedure, so first one, connect one cell, and so I'll draw the circuit diagram here. So I'm taking 1, 2, 3, 4 cells. So ammeter, next one, a resistor we have to connect, resistor, here I'm connecting resistor, switch, so here I'm connecting the potential difference. So positive terminal, negative terminal, current is flowing, okay, here and here. So first you have to connect one cell and note down the reading of ammeter and voltmeter, and connect to 2 cells and note down the reading of ammeter and voltmeter. Connect to 3 cells and note down the reading of ammeter and voltmeter. So repeat the process, okay. So one cell and second one, 2 cells, connect to 2 cells, note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. First you have to connect one cell and note down the reading of ammeter and voltmeter, and connect to 2 cells and note down the reading of ammeter and voltmeter, and connect. So repeat the process for 3 and 4. Okay, repeat the process for 3 and 4, and observe the reading of ammeter and voltmeter and mention in the tabular form given. So this is the tabular form, you can check this is the tabular form. Okay, serial number, number of cells, ammeter reading, voltmeter reading, V by I form. So serial number, number of cells, ammeter reading, voltmeter reading, V by I form, that is equal to R. So 1, 2, 3. So 1, 2, 3, 4, 1, 2, 3, 4. Okay. So if you draw the tabular form, given below, understood? So if you draw the tabular form, then automatically, so you can observe this one. So now if you draw this graph, VI graph, so I'm taking the VI graph like this. So V on y axis, I on x axis, the graph is straight line. Starting from origin. Okay. So, right. So, what do you mean by the graph is straight line or starting from origin? Means, so V is directly proportional type. V is directly proportional type. Potential difference is directly proportional to current. And so we are starting with one cell, right? That time ammeter and voltmeter reading will be 0. That is the reason we are starting from origin, right? And so it is directly proportional means, so it is linear, right? So this is for ohmic conductors. The graph is for ohmic conductors. So the graph is for ohmic conductors. Okay, the conductors which obey Ohm's law, those are called ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. So V on y-axis, I on x-axis. So the graph is curved. The graph is curved. So I hope it is very clear. The graph is curved. The graph is linear for ohmic conductors. The graph is for non-ohmic conductors. Non-ohmic conductors. So what do you mean by ohmic conductors? The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Right? Yes. So this is about Ohm's law. Next one. So difference between resistance and resistivity. Difference between resistance and resistivity will discuss. So after that we'll discuss about resistors are connected in series combination, resistors are connected in parallel combination, everything we'll discuss. Now resistors are connected in series later, after discussion of, after completion of differences between resistance and resistivity, we will discuss about resistors are connected in series combination, resistors are connected in parallel combination, right? Yes. So now difference between resistance and resistivity. Difference between resistance and resistivity. Resistivity. Okay, resistivity. So let's start. Point number 1. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. So R equal to rho into L by A. R equal to rho into L by A. Okay. So R equal to rho into L by A. R equal to rho into L by A. So point number 1. Resistance depends on temperature. Resistance depends on temperature. And the second one, resistance depends on nature of the material. Nature of the material or material of the conductor. Nature of the material. Understood? And here also resistivity rho equal to RA by L. Resistivity equal to rho equal to RA by L. RA by L. So SI unit is very important. So rho equal to SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. So rho equal to ohm meter. Very important. So 2 marks question. 2 marks question. And sometimes 1 mark also, MCQ's point of view also. These points are very important. Very important. Understood? And the next one, coming to the next one. So resistivity depends on temperature. Resistivity also depends on temperature. And coming to that, resistivity depends on nature of the material. Nature of the material. I hope it is very clear. So these are the points. These are the points. And here resistivity does not depend on dimensions of the conductor. Okay, so physical dimensions, we can say physical dimensions. Resistivity does not depend on physical dimensions, but resistance depends on length and area of the cross section. That is nothing but physical dimensions of the conductor. Physical dimensions of the conductor. I hope it is very clear. So these are the points. These are the points. So related to resistance and resistivity. Resistance and resistivity. So now we will discuss about resistors are connected in series combination. Resistors are connected in series combination. Okay. So now see, resistors are connected in series combination. So let's start connecting the resistors are in series combination. So you can see resistors are connected in series combination. Resistors are connected in series combination. In series combination. So resistors are connected in series combination. First one, so I am taking 1, 2, 3. So that I am connecting ammeter. Next one, battery, switch. So here positive terminal, negative terminal current is flowing. So across R1, R2 and R3. So across R1 I am connecting V1. Okay, so across R2 I am connecting V2. Across R3 I am connecting V3. Okay, so here you can observe. Understood? Across R1 V1, across R2 V2, across R3 V3. So hi everyone, welcome to the class. So if you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe the student brand. Okay, so yes, now resistors are connected in series combination. So in the series combination, current is same. Is equal to I1 equal to I2 equal to I3 equal to I. And from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. Okay, from Ohm's law, V equal to IR. So that is nothing but Vs equal to V1 plus V2 plus V3. Okay, that is nothing but IRs equal to IR1 plus IR2 plus IR3. So I am taking I common. So here see, so as I mentioned, from this we'll get IS, RS, I1, R1 plus I2, R2 plus I3, R3. As I mentioned, IS equal to I1 equal to I2 equal to, oh my god, here I3. I3. So we can take so here I3 equal to I, right? So like this. So I am taking I common. I am taking common R1 plus R2 plus R3. So I get cancelled. Then the remaining values RS equal to R1 plus R2 plus R3. So resistors are connected in series combination. If resistors are connected in series combination, Rs equal to R1 plus R2 plus R3. Okay, if n number of resistors are connected in series combination, n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. I hope it is very clear. So if resistors are connected in series combination, this is the formula. Now I will discuss about resistors are connected in parallel combination. Resistors are connected in parallel combination. Okay. So based on this one, we'll do problems. Resistors are connected in parallel combination. Parallel combination. Parallel combination. So here you can observe. So I'm connecting like this. 1. So 2, 3. So those I'm connecting like this. Ammeter. So battery. Switch. Across this one I am connecting voltmeter. R1, R2, R3, across R1 I1, across R2 I2, across R3 I3. Positive terminal, negative terminal, current is flowing. Positive terminal, negative terminal, current is flowing. Okay. So positive terminal, negative terminal. Now we can observe. So resistors are connected in parallel combination. Right? So now so in this case Vp equal to V1 equal to V2 equal to V3 equal to V. Because center the combination potential difference is same. Even though current is different, but potential difference is same. So that's why I'm taking now from Ohm's law V equal to IR, I equal to V by R. From Ohm's law V equal to IR, I equal to V by R. IP equal to I1 plus I2 plus I3. That is nothing but V by RP equal to V by R1 plus V by R2 plus V by R3. So I'm taking V common. 1 by Rp equal to, so V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So V we get cancel. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if resistors are connected in parallel combination, the formula is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Resistors are connected in parallel combination. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, Rp equal to R by n. Rp equal to R by n. So this is the formula, right? Okay. So now we will discuss about heating effect of electric current. Heating effect of electric current. Heating effect of electric current. So the potential V equal to W by Q, W equal to V into Q. So power equal to rate of doing electrical work, that is VQ by T. So we know that Q by T is I. So Q by T is I. So P equal to V into Q by T. So that is nothing but VI. So electrical energy equal to P into T. So what of the energy is given to the conductor, that will become, so that will be converted in the form of heat. So H equal to VI into T. We know that V equal to IR. V equal to IR. So IR into I into T. So H equal to I square RT. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Okay. So this is about heating effect of electric current. It is also known as Joule's law of heating. I hope it is very clear. So now we will do the problems. So I'll write the problems. Okay, so let's solve the problems. So let's start the problem, solve the problem. Consider the following circuit. Consider the following circuit. So this is the 5 ohm, 8 ohm, and ammeter, and 12 ohm resistor. 12 ohm resistor. So that is connected here. Circuit diagram I'll draw little bigger. Five ohm, 8 ohm, 12 ohm. That across the 12 ohm, so we connected voltmeter. So voltmeter is connected here. Okay, so here you can see positive, 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 positive. So 5 volts. What would be the readings of? What would be the reading of? What would be the reading of readings of the ammeter and the voltmeter when key is closed. When, so you can, so I'm removing this one. When key is closed. When key is closed. Key is closed. Can you let me know the ammeter reading means current. Current reading and voltmeter reading is potential difference. So they asked what would be the readings of the ammeter and the voltmeter when key is closed. See, you have to observe. So don't take potential difference here. So they are asking about across 12 ohm. So 12 ohm is across 12 ohm resistor. They are asking about potential difference and overall current they are asking. So try to find out. Try to find out how much you got. So that is the question. Try to solve. I'll give time. So I'll go for 4 minutes or 2 minutes. So 4 minutes time. So meanwhile, subscribe the channel. So after 4 minutes, I'll explain. Okay. So let's solve the problem. So okay, so check once here. So when key is closed, when key is closed, when key is closed, so first you have to take entire resistance. So given data, what is the given data? So see here, so total resistance R equal to, this is R1, R2 and R3 I am taking. So R1 plus R2 plus R3. So that is nothing but 5 plus 8 plus 12. That is nothing but 25. 25 ohm. So R equal to 25 ohm. Right? So total resistance. And potential difference is given. How much? 5 volts. So we have to find out. So what they are asking to find out? Voltmeter reading and ammeter reading. Ammeter reading is the current. So potential difference across 12 ohm resistance. Across 12 ohm resistance we have to find out. Okay. So for that, first find out current V equal to IR. From this data we can take V equal to IR, I equal to V by R. So V equal to how much? 25. Uh, V equal to IR. So it will be reverse, right? Yes or no? We are finding the current. Total resistance, correct, only 20, 25. So potential difference is 5. So V equal to IR. So I equal to V by R. 5 by 25. So 5 1 ja, 5 5 ja. So I equal to 0.2 ampere. Is it correct? 0.2, is it correct or not? Let me know. So yes, so 10, 0.2 correct. Now, so they are asking to find out potential difference across. So anyway it is connected in series combination. So V12 potential difference across. So I overall and R12. So resistance 12 so we can take, we can consider like this V0 I0 like that. Okay. So now potential difference we need to find out. Current is 0.2 and resistance is 12. So how much? 24, 2.4. Is it correct? 2.4 volts. Those who got the correct answer, very good. Very good. Check once again. So check once, let me know the answer. Is it correct or wrong? So very good. Those who got the correct answer, very good. Subscribe the channel. So check once again. So key is closed. So total resistance 1, 2, 3. 3 resistors you have to add. So 5 plus 8 plus 12, 25. So resistance, potential difference given V equal to IR, I equal to V by I. 5 by 25. So 1 by 5, 0.2 ampere. V equal to IR. We have to find out across for a, you can write for 12 ohm resistor. Okay, so like this you can write. So V equal to IR, V equal to 0.2 into 12. So V equal to 2.4 V. Is it correct? Let me know. So those who got the correct answer, very good. So if it is correct, please do like, share and subscribe. Okay. So one more question I'll give. So meanwhile just go through the answer. So next one, we'll discuss one more. Four ohm R1, 3 ohm R2, 6 ohm R3 current. So potential difference 12 volt. Find out R value, overall R value and overall current value. Can you find out? Let me know the answer. Here you can check. So these two are in parallel combination. These two are in parallel. Okay, so what you have to do? 1 by 3, 1 by Rp equal to 1 by 3 plus 1 by 6. 1 by 3 plus 1 by 6, right? So you have to take 1 by 6. So that is nothing but 6. So 2 plus 1. 2 plus 1 you have to take. 2 plus 1. So 3 by 6. That is 1 by Rp. Rp equal to 6 by 3. That is nothing 2. So Rp equal to 2 ohm. Okay. So I hope it is very clear now. So that will be added to in series combination. So R equal to 4 plus 2, 6. Overall 6. So 2 plus 4, 6 ohm. So R equal to 6 ohm. Coming to the potential difference already given here. So V equal to 12 volts. Now V equal to IR. I equal to V by R. So V equal to how much? 12. R equal to how much? 6. So answer is 2 ampere. Is it correct? Answer is 2 ampere. Is it correct? Let me know if it is correct. Do like, share and subscribe to Student Brand. So check once here. 1, 2 parallel. So we did 2 you got. So this in series to this one. So please 2 plus 4 is 6. So R equal to 6. So potential difference is 12. V equal to R equal to V by R. So 12 by 6, 2 ampere. Okay. So thank you so much. So next one more question. Let's try to solve. Just check one. Meanwhile check the answer.